have to solve the questions.
Mhm.
Uh, we have some range like 2.0 to 2.2, and then we do some approximation. Okay, it will be around 0.78, 0.77. So is it fine, sir, in exam
No, no.
0? Huh?
See, wherever surface finish factor required, wherever size factor required, wherever reliability factor required, we will provide the table as well as the chart.
Okay, sir.
Because, I mean, even any engineer, they have to follow the chart. I mean, from the design data book. Okay. And
Mm.
material properties also we have to provide. Because, I mean, we cannot, all the things we cannot remember. And
Yes, sir. Like
we will provide the table. We will size factor, we will provide the table. Reliability factor, we will provide the table. Stress concentration factor, KT, we will provide the chart. Okay, the surface finish factor chart also we will provide based on the material.
talking about chart system, we do like suppose there is a we have some value on X and we have some value on Y. So then we need to find the value. Then we have range, right? From we don't have a discrete value for everything, so we have like range from 2.0 to 2.1, and then we find. But actually, sir, in X, whatever we have,
Yeah,
we.
I have understood, but because even
Sir.
standard chart, you are saying that y, for example, y-axis 2.1, 2.4, 2.2, 2.4, 2.6, but
Uh-huh.
x-axis they are given 400 and 400 Newton per mm squared to 500 Newton per mm squared, like that.
Uh-huh.
Suppose our x data is stress value is 450 Newton per mm squared,
Yes,
then
sir.
value of y going to be, we can't exactly say that. It may be a 2.08, someone may 2.08, someone may 2.06, like that you are asking, right?
Yes, sir. Yes, sir.
It's no problem, that small variation doesn't matter, but your range, your value should not be above 2.2, above 2, below 2.1.
Okay, sir. Thank you.
Are you clear?
Yes, sir. Yes, sir. Absolutely.
Okay, no problem. Okay, guys, very good morning. Okay, first. And one more thing I would like to tell you. Okay, first I finish that, then we go for the today discussion. Now, all updated slides I shared you that yesterday. Anyway, I mean, the same slide, updated version I shared you in the last. I mean, it's yesterday. Okay. Now, if you want, okay. If you want, please hold this written, whatever I have written in this slide. If you don't like, I already given to access the slides. You just click that, you remove that. All the things you can remove it, then you can study. So that way, which one you better, you do it. Because why I'm saying that, when I was teaching during that time, I have written many things. The students' mind also may be observed. Okay, these are the things. I mean, the faculty was explained like that. So that's what I didn't. I mean, remove those things. If you want, you can remove it and go for the preparation. And one more suggestions, guys, prepare your assignment and submit whatever we taught the class, example problems, and and a few more example problems in your Bandari book. You follow that, so enough. And assignment, if you covered assignment, sure you are going to get good mark. Because you and I can suggest you can refer any book. The whatever we discuss, that concept will be there. Whatever we discussed, that problem only will be there, but they might have been changed the values for diamond. They might have been changed the component dimension, might have been changed the mean force direction, might have been changed the force magnitude. That's all. But the component whatever we discuss in our class, that is enough, because we cannot go beyond that also. Okay, we don't have a time also. That is so enough. So suppose for a courtesy you want to do more design, then go for any book. If you are finding any difficulties, bring to me. I will explain you that. I mean, often I am telling that. I mean, if any doubt, please come to me. No problem. Okay. but similar problem. Most of the book they are following similar problem, but only the concept you have to keep in mind. That's all.
Sir, do we need to practice problems from curved beams? Curved beams.
What?
Sir, in the first assignment, you gave one problem from curved beams. Sir, a C
Hmm.
clamp example question you have given for answering it.
Hmm. I forgot what you are saying. I'm not getting. Biswal, please. Any repeated question, Biswal? Amarnath?
No, sir, you have gave one question from Bandari book, curved beam problem, sir.
Yes.
It's a question number 4.8 uh, C clamp question, sir. You have given the diagram for that.
Okay. Any difficulties?
Sir, I think that can't be solved from the usual method because in the curve in the neutral axis won't be lying in the usual center, sir.
Yes. Yeah, you have to find out the moment of inertia with respect to IX, IOI, right? That's what you are saying, right?
No, sir, we have to find the eccentricity of the like we have to find the new neutral axis and then you have to calculate the
Yes.
radius radii
That
and
is,
then you have to calculate it.
yeah. When you are going for finding new central axis, this moment of inertia also you have to play. Are you getting?
No, sir, but in curved beams like C clamps and S clamps, the neutral axis won't be lying at the center, na, sir. If the cross section is uniform, then
Hmm.
the neutral axis won't be lie at the center centroid. Its usual centroid, like it will shift somewhat,
Hmm.
like somewhere it will be
Okay.
located, but not at the center. So that's
Okay.
the problem.
Yeah. Okay. Now, I mean, are you solved or not yet solved the problem?
Sir, using the formulas given in the book, I solved for different sections. Different formulas is there for like eccentricity
Yes. And if you have any
and
difficulties, I'm ready to
and
discuss the problem. Otherwise, you can do it. Okay. No, bro, I have understood that. That is a C clamp problem. But C clamp problem, we didn't discuss in the class, right? Correct?
yes, sir. Yes, sir. We didn't discuss.
Yeah, got it. That is C clamp problem. That is the forces are acting towards outward direction. I mean, the C clamp problem that, inner side, the cross section of the C clamp dimension we have to define. It's interesting problem, a very interesting problem. Yeah, please solve the problem. Sure, if any have the difficulties, I provide the answer, no problem. Okay. Okay, guys, I go to today minor, evening 5 to 5:30. Maximum maximum 25 minutes. 35 to 40 questions. Objective type questions. If you are very good in class, class notes as well as whatever we discuss in the class, then you can easily score the marks. No doubt at all. It's very small problems. Even those problems may not require the calculator. You can directly calculate this value and within minute you can evaluate. So you only have to understand the problem. Okay, very simple problem mathematics. Remaining are concept based and formula based. These are the things. I think 12 marks. The first minor one, 12 marks. Minor two, whatever, maybe 10 or 12, based on students' assignment. If everything assignments are similar, then I may reduce the assignment marks. If assignments are somewhat different from each student, then I may hold the more marks. That's what my intention. Okay. Are you able to see my slide?
Yes,
PPT.
sir.
Yes, sir.
Yeah, thank you guys. Now Now we come to the next topic. Then the last class, slightly we briefly discussed about the temporary joint. What are the temporary joints? Bolt and nuts used, to connect the joint, to join the two components. Where it will be required to join first of all. Wherever in a mechanical system, wherever more than two components or more than two components to functioning, then the two components to be connected in appropriate manner, either using permanent joint or temporary joints. Once we are going for the design, we should know that either we go for the permanent joint or temporary joint. Then based on that permanent joint or temporary joint, we have to define our joint. That joint is, it may be a quarter joint, maybe a nut and bolt joint, maybe a power screw joint, right? These are under the category of temporary joints. But what are the permanent joints? The permanent joint, it cannot be easily dismantled. But temporary joint, it can be easily dismantled without destroying the components, right? But bolt and nut, it can be easily dismantled. If we are using power screw to join the components, it can be easily dismantled. If we are using cotton pins, the joint can be easily dismantled without destroying the component. These are the temporary joints. And it can be assembled and disassemble, or assemble as well as disassemble very easy. Fabricating and removing the component very easy while using the temporary joint. Okay, but in permanent joint, once we connected two components, for example, using gas welding or arc welding or soldering or whatever, and bracing, then very difficult to remove the very difficult to dismantle the component and components. While dismantling the components, we are destroying the components. Hence, permanent joints, wherever required, that place only we can use, but we cannot expect the component while remove the component without damage. Okay, so that's what based on place we have to use for, especially mostly wherever we are transmitting the power, we are mostly using temporary joint. For example, inside IC engine, we are inside IC engine, that crank, the cart, that piston and the connecting rod, connected by pins, right? We are not welded in the inside the portion. Okay, that connecting rod other end connected to the crankshaft, there also we are not using welded joint. Okay, there also we are using temporary joints. Wherever we are transmitting the power, we are mostly using the temporary joints, because while using permanent joints, it may form the crack or flaw inside the material, and very difficult to, dynamic conditions, very difficult to use permanent joints like welding, those things. Okay, while transmitting the static load, maybe permanent joint may be good. Okay, now see here, these are the types of temporary joints. What are the temporary joints? Quarter joint, knuckle joint, and fasteners, design of quarter joint. Now we are going to discuss the design of quarter joint and knuckle joint. First, we discussed in this class design of quarter joint. Form of screw threads, nomenclature of screw threads we are going to discuss. Then thread series of the destination of the thread series, and power screws and their advantages of the power screws, V threads and stresses in screw threads. These are under the category of temporary joints. Design of bolts based on uniform strength, the corresponding empirical relations for initial tightening. Those things we are going to discuss now. Now, first we start from the quarter joint. In the quarter joint, there are three parts very important. One is this part. The right hand side part is called as spigot. The left hand side part is called as socket, and the middle portion is called quarter. Which component we are using? We are trying to securely connect these two components. Spigot and socket. We would like to connect. Then we are using this carter. The carter is passing through the, appropriate slot provided in the spigot and socket. Okay, just see this. This is the temporal joint. Now, what is the application? See here, carter joint we are using here. Quarter joint in bicycle you are using. Quarter joint in reciprocating motion of steam engine you are using. Reciprocating motion here, quarter joint we are using. Okay, now see here, quarter joint. There are a lot of applications in the quarter joint. Okay, application in quarter joint. Now I put one video. So next class I will show you more video, but just very basic videos. Just see this video. Are you able to see the video?
Grammarly provides suggestions for grammar, spelling,
Yes, sir.
style, tone, and more.
Yeah, actually in this video they are showing the cartridge looks like a uniform width and a uniform thickness. Cartridge is uniform thickness, no doubt at all, but the length going to be a slightly tapered. But just don't keep in mind this cartridge is always uniform length. The length is slightly tapered. Okay, just that is needed. Why the slightly tapered required, we will see that in the discussion later. Your socket is hollow region. Okay, please keep in mind, because while we are going to analyze discuss the diamond, how to design the diamonds, and then that time it will be required. Your spigot is always mostly in solid section, solid rod. Okay, now we move to this. Quarter joint failure animation. Just see this video also. It will help you to understand easily while we are going to define the dimension of the quarter joint based on that load acting in the component.
Looking for a home to escape from stairs? Increase property value, introducing Lupa.
The blue region is failure region, blue shadowed region. Now that is tensile. Now this is shear in the socket. This is also shear in the spigot. Spigot tension. So just very important. This is Carter failure due to shear in the double shear. I mean this cross section and this cross section. Okay. Now see here, we move to yeah, 1 minute. Take my pen. So now you might have been understood the Carter joint can be used to connect the I mean in generally Carter joint can be used to connect the two coaxial rods. In the coaxial rods, which mean it can be subjected to either tensile or tensile or compressive force in the coaxial rods. Okay, now it's also the Carter joint also it can be used to can be used to connect the rod on one side with the some machine part. Like a crosshead or base plate on the other side. Okay, and mostly this is the typical applications you see here. Joint between the piston rod and the crosshead of the steam engine. I have shown you one example, the second slide, and joint between the slide. Here also the piston, it's not rotating. This is a reciprocating motion. Okay, now the joint between the slide, the spindle and the fork of the valve mechanism. Here also sliding motion, mostly sliding motion. Joint between the piston rod and the tail or pump rod. Here also sliding motion. Okay, joint between the piston rod and this sliding motion. So mostly we are using for that. Mostly we are using for this Carter in lot of applications while transmitting the not rotating. Mostly we are using for sliding motion or reciprocating motion. We are using this Carter. Now, the Carter joint we have seen how they are assembled. Just now we have seen how it is assembled, right? Now, now we discuss about more details about the Carter joint. Now, how the Carter is holding these two components tightly. That's what we are going to discuss now. I mean, this tightly holding because of the wedge action. Yeah, please 1 minute. Yeah. I mean, the principle of wedge action is used in the quarter joint. Hence, the wedge-shaped piece. I mean, you might have been seen. This is a wedge-shaped piece. This is the width of the quarter. This is the width of the quarter. This is the length of the quarter. Now, I mean, this is looks like this is a tap. This is a little tapered. The length is little tapered with the help of the taper, as well as this is the edges are slightly curved. Then we are obtaining the wedge shape action. With that wedge shape action, the quarter, with the help of this wedge shape action, the two components, I mean spigot and socket, are tightly held. Is tightly held with the help of the wedge action. Okay, so the quarter is working. The principle of quarter is with wedge action. Now, that's what the joint. I mean, the quarter is a wedge-shaped piece made of steel plate, made from the steel plate, and also the joint is tightened and adjusted by the wedge action. The joint, I mean, while inserting the quarter, for example, while inserting the quarter here through the slot. I mean, first we have to insert the quarter. First we have to insert the spigot and the socket end. I mean, then when we are inserting this, this spigot slot and socket slot must be in same orientation. I mean, it will be acting as a common slot. While match this orientation properly, then we are going to insert the quarter on this slot. While inserting the quarter in this slot, we have to apply the mild hammering force on the quarter for creating the creating the tighten between the two components. Then only the two components going to have two components is tightly held. Hence, we are applying the mild small amount of hammering force on the quarter. While applying the small hammering force on the quarter, sorry. Okay. While applying this small hammering force on the quarter, and due to the wedge shape as well as the tapered design, the quarter is securely held these two components as well as tightly held the two components at the proper orientation. Okay. Now, here, quarter is uniform thickness. The thickness is uniform thickness T. This is uniform thickness T, length is L. Okay. Now, this is a width. Width is, we are referring that B, better to avoid W. This width is referred as B. Okay. Now, generally, that a quarter tapering, we are using 1:24. 1:24. For example, 1:24. For example, 50 mm quarter length. It may be the 2 mm tolerance. 2 mm taper. Here maybe 50 mm. Here maybe 49 or 48. 48.5 or 48. 48.5 or 49, we are using the taper. Okay. Now see here, before entering into the design the component, we have to understand the notation here. Whatever we are applied the force here, P is mentioning tensile force. D is the diameter of the each rod. Diameter of the each rod is nothing but this end and this end. This is our diameter of the rod. Okay, this is the diameter of the rod, this end and this end diameter of the rod. Now D1 is outer diameter of the socket. Outer diameter of the socket. Socket is going to have hollow section, hence outer diameter of the socket. This is hollow. This is socket have, I already told you in the video also. I mean, this in the video also we have seen that this is a hollow section. If it is hollow section, then only we can insert this spigot, insert we can insert the socket. Okay, that is, I mean, in outside diameter D1 of the socket, and D2 is there. I mean, diameter of the spigot, diameter of the spigot, or inner diameter of the socket, inner diameter of the socket. Please keep in this, I mean, notation in mind. And D2, D3 is the diameter of the spigot collar. Where is spigot? This is a spigot collar. This is spigot collar. Okay, and I mean, A is the distance from the end of the slot. A is the distance from the end of the slot here. This is the end of the slot. I mean, this end. This is the end of the slot, because this is the end of the slot here. This is the end of the slot. Okay, this region, from this distance to this distance. Sorry, not that one. This here, this distance to here, where the quarter is sitting. Quarter is sitting here. Okay, A and B. A and B. B is nothing but width of the quarter. As I told you, this is width of the quarter. C is a axial distance from the slot end and the socket collar. C is the actual distance between the slot and socket collar. I mean, here you can able to see here this region. That is nothing but axial distance from the slot to slot. Here we have seen no slot here. This slot ended to this corner distance. That's what you're saying. Axial distance from the slot end to the socket collar. Slot end of the socket collar, here to here. That is C. Okay. Now T is the thickness of the quarter. T1 is the thickness of this spigot. This is the thickness of this spigot. This thickness of this spigot is nothing but T1. I mean, L is the length of the quarter. This is the length of the quarter. Now, any furthermore, I mean, notation, we will see all the notations, because here we have given all the things we covered. Now we move to the this one, one by one design based on that tensile force, tensile failure of rods, and tensile failure of the spigot, tensile failure of the socket. One by one we discuss. Okay. Now, I mean, in this quarter joint, the quarter joint, whatever we constructed the quarter joint, right? By using the principle of wedge action, right? I mean, by using the principle of wedge action, what is the basic principle is playing in this? The action, I mean, the principle that action and reactions are equal and opposite. The actions and reactions are equal and opposite. But here, the horizontal force must be equivalent to 0. I mean, while considering this component in the socket, what are the horizontal force acting in this component must be equal to 0. What are the components, horizontal force component acting in this quarter must be equal to 0. What are the components force acting in this spigot? That summation must be equal to 0. Then only the component going to be equilibrium condition. Then we can perform our mechanical function. Right? And now this is one rule we should consider while designing the component. And another thing, I mean, this is the important thing we have to consider while designing the component. Now see here, here the force P is acting in the rod, tensile force. Then the top portion of the, I mean, socket collar P by 2, and bottom force P by 2, and top portion P by 2. But now here this is a right hand side force. For here should be a left hand side force for equilibrium the component. But while here this force is going to act, the same amount of force is going to act in this quarter. Here this is right hand side force. I mean, this is left hand side. The force acting in the socket end in the left direction P. Then when we are using to connect it along with this spigot, then we are using the cotter. Then what will happen? This portion going to be now tensile in the right hand side force. Then same amount of force, this region going to be act in the cotter. This is going to be act in the cotter in the rightward direction, opposite direction as compared to the rod. Hence, this is a force is in right direction. Now in the top, while going to happen shear, what will happen while shearing force? How the shearing happening? This then here the P is going to the shear. This is the top shear. Then the cotter, when insert the cotter here, this is the top portion one shear. Then force going to be P by 2. This also P by 2. Okay. While this force is left hand side direction, this force is rightward direction because of equilibrium condition, to maintain the equilibrium condition. But while considering this force acting here, then this region is engaged with the spigot end, then this side going to be in rightward direction. Rightward direction. Now this side, then again this side is rightward direction, leftward direction. Sorry, this side, this is the leftward direction. Sorry, this is leftward direction. Now here leftward direction, then this should be rightward direction for maintaining the equilibrium condition. Then summation of all this force going to be 0, or the resultant force going to be 0 in this component. Okay. Now we go for the one by one tensile failure of the rod. Tensile failure of the rod. I mean, this is the first we are considering this portion. Tensile failure of the rod. We have seen in the video also. What is the tensile failure here? Sigma T is equal to P by pi by 4 d squared. It's a very simple formula. P by pi by 4 d squared. Okay. Now, I mean, if we know the permissible stress based on the material properties we can obtain from the table, then we know what is our load. I mean, which design we are going. I mean, we always, our design is based on our load transmission only. We are not based on material, based on our application. Our application is how much load I want to transmit. How much load I am going to use in this arrangement, then we must know this, right? This also we know from the table. Now only then we can find it out what is the diameter of my rod end or spigot end, a socket end or spigot end, we can find it out. Okay, this is the tensile failure of the rods. Now I come to this tensile failure of this spigot. Tensile failure of the spigot. See the figure. This figure. This is the tensile failure of this spigot. Okay. Now in this section, what is area? Spigot. This is what is this area here? I mean, this is a cross section we are focusing now. This is a cross section we are focusing now, because tensile, while we are connecting while we assembled with the cotter, this is the force and the cotter slot is here. The cotter is passing through the spigot. As we know already, spigot is, I mean, solid rod. It's not a hollow section. Then this is the area we know. Then this area that where the spigot is sitting, cotter is sitting in this through the slot of the spigot, then that portion we can't consider. Then we know already, earlier we discussed in the last chapter also the basics of this. Then what is the area here? I mean, section XX area is pi by 4 d1 squared d2 squared minus d2t. This area d2t. Okay, I'm now apply this. What is the force here? This force. This portion is going to be tensile, right? Tensile of the this region going to be a tensile of the tensile in the tensile in the socket. Okay. Now from the socket, now What is this sigma T? Tensile stress is equal same P by A. Now, I mean, earlier we know D, right? Earlier we know D. Now, now we would like to find out D2. From these relations, we are able to find out D2. Okay, P we know. We may be able to find out now D2. D2 or T. Okay, we discuss the T later also. D2 or T we are going to find out. This is the tensile failure of the spigot. This is a tensile failure of the spigot. Earlier we discussed tensile failure of the rods. Okay, 2 cases now completed. Now third case, I mean, here the diameter of the spigot or inner diameter of the socket D2 can be determined. Diameter of the spigot or inner diameter of the socket can be determined. Okay, I mean, here we are assuming from the standard table we can assume even up to this calculation we can assume that T is equal to 0.31 D. Okay, anyway, we are going to discuss how to find the T value, thickness of the quarter also, but quarter value quarter thickness we can consider from the standard table also. I mean, now sometime we are going to design our quarter and we are going to compare with this also. Either our design is, I mean, acceptable or not acceptable, that can also we are going to do later. Okay. Now I come to the tensile failure of the socket. The third case I am coming to the tensile failure of the socket. Okay. Now, yeah, this is here. See here. I mean, this figure. Now we take this figure. And we are considering this region. This is the socket. Now the socket is subjected into tensile. This socket end is subjected in tensile. Now this is socket end. This is a hollow region. What I told you. This is the hollow region. I mean, now see here. This is the region of interest we are going to consider. This is the region of interest. Okay, now see the side view of this. This is the hollow region. What is the area here? Pi by 4. I mean, D2 squared, D1 squared minus D2 squared, right? Then minus of this region, D2 minus D1 into T. That is the area of this, right? D2 minus D1 into T. I mean, what is this area? I mean, without a slot, what is the area? What is the area? Without a slot, what is the area? Pi by 4 D2 D1 squared minus D2 squared. Okay, this is the area of this without slot. Now slot is playing because through the slot we are connecting this quarter for holding these two components. Hence, we would like to subtract that area. Then now that new area, this is required area now. Minus of D1 minus D2 into T. Okay, now what is the force is acting in this? What is the force is acting in this? I mean, force is a tensile force, but that's what we discussed. That's what I told you in the heading. No, I mean tensile failure of the socket. Now again, sigma T is a permissible value. P by this is A dash, not A1. Okay. Now this is from this. What are the information we are able to collect from this? I mean that diameter. From this equation, that the socket diameter D1 can be determined. D1 can be determined from this relation. Okay. Now I come to the shear failure of the quarter. Now quarter shear. Now see this figure. This is the third case. I mean, socket under in tensile. This one. Now I come to this fourth one. Fourth one. Fourth one is shear failure of the quarter. Shear failure of the quarter. The quarter is going to have a failure in both sides. The quarter now inserted inside the slot, while that socket and spigot are inserted. Then the common slot, through the common slot, the quarter is inserted. Right now, quarter, how many shears here? In the top portion of the quarter going to be shear, the bottom portion of the quarter going to be shear. But here, which one is important? This is the thickness. Thickness is going to be involved in this shear of the quarter. Now, bottom portion here. Okay. Now, find out the shear. Very simple. Two shear. What is shear? This is shear area. This is the B. Width of the quarter is B. Thickness of the quarter is T. Then what is the shear? Shear stress is equal to, we know already shear stress is equal to, right? Shear stress is equal to tau. Tau is equal to, load is same. Load is same. P by 2BT. Okay. Now from this, we are able to find out width of the quarter. From this relation, we are able to find out the width of the quarter. B is equal to what? As I told you earlier, here we can use this relation for finding the T, thickness of the quarter. Now we are able to find out what is the width of the quarter. Then width of the quarter. Now come to this next failure. This is shear failure of the spigot end. Spigot end. For this figure, where is spigot? These are in the socket, right? Yeah. Come to this figure. This is the B. Here, where is the B? Yeah, this one. Okay. See here. We know that spigot is solid rod, but when the quarter is inserted through the slot, this is our slot, right? In the slot we inserted the quarter. Then which region going to have failure? Which region going to have shear? Then the quarter, this region going to have shear. This is what we have kept it here. Okay. Now what is that region? That region I am considering A. Okay. A. This is the dimension A I am considering A. This dimension I am considering D2, because diameter of this spigot is D2. Then this is a D2. This is a region going to have in shear. Now this is a fourth case. Now now the spigot is subjected into shear failure. Then tau is equal to sheared area. Sheared area is nothing but P by 2. Okay, P by 2 into A D2. Because here also both sides. Now this side and other side. Okay, this side and back side. Then P by 2 into A into D2. This A D2 is the area of this shear. Then what are you able to find out from this relation? From this relation we are able to find out A. From this relation we are able to find out A. Because earlier relation, this is a permissible stress value. Tau is permissible stress value. D2 we have already found it. Then P we know, then only we are going to find out A, what is this area. What is this dimensions of A. Okay. Now now I come to the next case. This is the next case is now subjected to other cases are now this is the shear failure of the second end. Yeah, tell me.
So can we stop here, sir? We have class from 9 to 10.
Okay, I stop it here. And okay.
Attend.
Yeah, okay, okay. I think, okay, we discussed the next class. Okay, this is the fourth case we completed. Okay, fifth and sixth, there are a few more cases are there, 5 cases are there. We discuss in the next class. Okay, thank you for your gentle reminder. Okay. Once, if you are understanding clearly, Carter joint, the later knuckle joints are very easy. Okay, I mean, why I'm going in the detailed manner, because the same concept will be extended to different application in the next subject, design of transmission elements. Okay, that's what I'm explaining here more. Now I come to the okay, guys, if you have any doubt, please go ahead. Otherwise, I can take attendance. Chat box, any questions? Okay, I kindly request you that today evening you are going to have exam 5 o'clock. I will put the time 5 o'clock. All are in objective type questions, maximum 35 to 40 questions. But the questions are going to be shuffled. I mean, we prepared more than 50 questions. I think 60 questions. I think that questions going to be shuffled. Also, every student is going to have different questions at a time. Okay. Be careful. And second thing, our exam is the first exam, right? I mean, our DME is the first exam, right? In the mid exam or second exam?
First exam, sir.
Yeah, first exam. Yeah, I mean, beginning of the class also I told, I mean, during that time only 30 students were there, 30 to 35 students were there. Now again I'm repeating, concentrate your class discussion, whatever we discuss the problem in the class, and all example problem in the Bandari book, please thoroughly practice it, and assignment problem be thorough, and submit the assignment by before, I mean, on or before coming day after tomorrow. Okay, submit. Already the link is provided. All the videos I updated in the link, uploaded in the link, as well as the updated slides also uploaded in the LMS. Okay, please go through that. If you have any doubt, please, I mean, you can mail me or you can call me, no problem. Now that question going to be question pattern, our DME mid-exam question pattern. I mean, the first chapter, design of static loading, maybe 40% of marks you may expect, and 40 to 30 to 40, and dynamic loading maybe 50 to 60% of mark. The total number of questions, minimum 5, maximum 6. Minimum 5, maximum 6 questions. All are descriptive type questions. Are you clear? Any doubt about mid-sem exam? Because this is after mid only we are going to meet. If any doubt, please ask me that. I mean, the data book, the chart, wherever recorded chart, wherever recorded table, it will be provided in the question. I mean, DME BTech. Okay.